Welcome to Bhagaskara Labs, the channel where we take the complexity out of technology and turn it into practical, hands-on learning. Here at Bhagaskara Labs, we don't just explain concepts, we guide you through real-world workflows so you can see exactly how technologies work in action. Whether it's cloud computing, networking, virtualization, or cybersecurity, our goal is to help you not only understand, but also apply these skills confidently in your projects or career. Today, we're focusing on NAT Gateways in AWS. NAT Gateways are a critical part of cloud networking. They allow instances in private subnets to access the internet securely without exposing them to inbound traffic. In this tutorial, we'll go step by step. We'll start by creating a VPC, configure public and private subnets, launch Windows EC2 instances, and then set up a NAT gateway to enable secure outbound internet access. Along the way, we'll test connectivity and see exactly how NAT gateways work in real time. So grab a cup of coffee, follow along, and let's dive into AWS networking together. By the end of this session, you'll have a complete, practical understanding of NAT gateways and how to implement them effectively in your own cloud environment. Before we jump into the hands-on steps, it's important to understand what a NAT gateway is and why it plays a crucial role in AWS networking. A NAT gateway is a managed AWS service that provides outbound internet access for instances and private subnets, allowing them to download updates, patches, or access external services securely. At the same time, it ensures no inbound internet traffic can reach those private instances, keeping them protected from external threats. Being scalable and highly available, a NAT gateway can handle increasing traffic without manual intervention, providing reliability for your applications. Finally, to function properly, a NAT gateway requires an elastic IP and a public subnet, acting as the bridge between your private resources and the internet. Let's take a closer look at why NAT gateways are needed and how they fit into the workflow we'll follow in this tutorial. Understanding why we need a NAT gateway helps make sense of its role in cloud networking. First, it gives private instances internet access, allowing them to reach external services when needed. Second, it enables these instances to download updates and patches securely, keeping your systems up to date without exposing them to the internet. Third, it helps keep private subnets hidden from the internet, ensuring sensitive resources remain protected. Fourth, a NAT gateway centralizes outbound traffic through a single gateway, simplifying monitoring and management. Finally, it ensures high availability for outbound traffic so private instances can reliably access the internet even as demand grows. This is the workflow step we'll follow to set up NAT Gateway in AWS and test secure internet access for private instances. Step 1. Create VPC and attach Internet Gateway. Create a VPC with CIDR 12.0.0.0/16 and attach an Internet Gateway. This allows the public subnet to communicate with the internet and sets the foundation for our network. Step 2. Create subnets and route tables. Define two subnets, a public subnet for public-facing resources and a private subnet for secure internal instances. Create separate route tables. The public route table sends traffic to the Internet Gateway, while the private route table initially handles only local traffic. Step 3. Launch two Windows EC2 instances. Launch two Windows EC2 instances. The public instance gets a public IP and allows RDP access from anywhere. The private instance has no public IP and allows RDP only from the VPC CIDR. Step 4. Test RDP access and browsing. RDP into the public instance, then the private instance. Browsing from the private instance will fail, showing it is isolated. Step 5. Create NAT Gateway and update private route table.
create a NAT gateway in the public subnet, assign an elastic IP, and update the private route table to route outbound traffic through it. Now, private instances can securely access the internet. Step 6. Test again. RDP back into the private instance, refresh a web page, and confirm internet access. The NAT gateway is working perfectly, providing secure outbound connectivity for private resources.
This is step 1 of our workflow, creating a VPC and attaching an internet gateway. First, create a new VPC with CIDR 12.0.0.0/16 and name it Demo VPC. Next, create an Internet Gateway, IGW, and attach it to your VPC. Finally, update the route table of your public subnet to direct traffic to the IGW. This ensures that resources in the public subnet can access the internet. This is step 2 of our workflow, creating subnets and route tables. First, create a public subnet with CIDR 12.0.1.0/24 and a private subnet with CIDR 12.0.2.0/24. Next, create a public route table and add a route for 0.0.0.0/0, pointing to the Internet Gateway. Then, create a private route table with only local routes. Finally, associate each subnet with its corresponding route table. This ensures proper traffic flow between public and private resources. In Step 3, we launch 2 Windows EC2 instances. First, the public EC2 instance. Place it in the public subnet, enable auto-assign public IP, and configure the security group to allow RDP from 0.0.0.0/0. Next, the private EC2 instance. Place it in the private subnet without a public IP. Configure its security group to allow RDP only from the VPC CIDR 12.0.0.0/16. This setup gives us one public-facing instance and one private, isolated instance.
In step 4, we test connectivity between our instances. First, RDP into the public EC2 from your local PC. From the public EC2, RDP into the private EC2 using its private IP. Open a browser on the private EC2. You'll notice no internet access.
This shows the private instance is isolated from the internet. Without a public IP or direct route to the Internet Gateway, it cannot access external websites, keeping it secure until we set up a NAT Gateway. At this step, we enable Internet access for private instances by creating a NAT Gateway. Go to the VPC menu, NAT Gateway, and launch it in the public subnet. Assign an elastic IP to the NAT Gateway. Next, Update the private route table by adding a route for 0.0.0.0/0, pointing to the NAT Gateway. This ensures all outbound traffic from the private subnet flows securely through the NAT Gateway, while the instances remain protected from inbound internet connections. At this final step, we verify that the NAT Gateway is working. Return to your RDP session on the public EC2, then RDP into the private EC2. Open a browser and refresh web pages on the private EC2. You'll see that internet access is now available. Websites load successfully, updates and downloads can be performed, and all outbound traffic flows securely through the NAT Gateway. Everything works as expected, confirming that the private subnet remains protected from inbound internet traffic while still being able to access external resources. This demonstrates a complete, functional NAT Gateway setup in AWS.
To summarize, a NAT Gateway is a managed AWS service that allows private instances to access the internet securely without exposing them to inbound traffic. Private subnets stay isolated, outbound traffic is centralized, and the service is highly available and scalable. By implementing a NAT Gateway, you can maintain both security and connectivity for private resources, a best practice in AWS networking. That wraps up our complete tutorial on NAT Gateways. We've covered everything from creating a VPC in subnets, launching EC2 instances, testing connectivity, to enabling secure internet access for private instances. If you found this tutorial helpful, please like, share, and subscribe to Bhagaskara Labs. Click the notification bell so you never miss a hands-on tutorial on AWS, networking, virtualization, or cybersecurity. We love hearing from our community. Leave your questions, feedback, or suggestions in the comments below. We read every comment and often feature viewer questions in future videos. Thank you for watching and supporting Bhagaskara Labs. Keep experimenting, stay curious, and happy learning. The cloud is full of opportunities, and we're here to guide you every step of the way.